Now let's implement the remove operation. So public void remove node. We give it a string. Once again, look at the interface of this class. From the outside, we always pass string objects. We don't know that this graph internally uses a node object because that's an implementation detail. So all these methods take string objects, okay? Now, in this method, first we want to make sure that this label represents a valid node. So let's declare a variable node, and here we call nodes.get label. Now, if node is null, we can throw an exception or simply return. In this case, I would prefer to return without throwing an exception, because if someone passes an invalid argument here, it's not the end of the world. Maybe that node was already deleted, so we don't want to yell at them. In contrast, in the add edge method, if someone tries to establish a connection between two nodes and these nodes are not valid, we have to tell them. So now we have a valid node. How should we remove this from our graph? Well, we have to go to our adjacency list, and for each node, if that node is connected with this node, we have to make sure to remove that connection, okay? So for var n in adjacency list dot key set, this will return all the keys, right? So that would be every node in this graph. Now we call adjacency list dot get. This will return the list of nodes that n is connected with, okay? Now from this list, we want to remove the target node. Now here we have a one-liner. We don't really need braces, so let's clean up the code. Once you remove all the links, then we're ready to remove this node from the adjacency list and the list of nodes. So adjacency list dot remove node and nodes dot remove node. That's how we remove a node. Now let's implement the remove edge operation. So public void remove edge. Once again, we need two parameters, from and to. Just like before, we want to make sure that the arguments that are passed here represent valid nodes. So we need two variables, from node. We go to nodes.get from, and to node, we set this to nodes.get to. Now, if either of these is null, we're going to return immediately. So if from node is null or to node is null, we're going to return. Again, we don't want to throw an exception. We don't want to yell at them. Maybe this edge is already removed. So attempting to remove it one more time is not the end of the world. Finally, we're going to go to our adjacency list, get the entry for the from node. This will return the list of nodes that this node is connected with. From this list, we're going to remove the target node. As simple as that. Now let's test our implementation. So back in the main class, let's create a graph with a few nodes. So graph.add node A, then B, and then C. Now let's connect A with B, A with B, then A with C, and finally print the graph on the console. So A is connected to B and C. Beautiful. Now, what if we remove one of these edges? So graph.remove edge A and C. Now A is only connected to B. What if we remove a non-existent edge, like A to D? Obviously, nothing happens. We don't get an exception. Now, what if we remove the B? So remove node B. Now, A is only connected to C. Beautiful. And finally, what if we remove A? All the links are gone, and that's why we don't see anything here, because there is no connection between B and C. However, if we add a connection, add edge from B to C, we should see that over here. There you go. So we have implemented the graph properly. Next, we're going to talk about traversal algorithms.